Hello everyone, today we'll talk about the solution to the problem unique length-3 palindromic subsequences. The main challenge in this problem is to think about this statement, about what we are being asked to calculate, and simplify it as far as possible so that the final implementation becomes easy. Now, if you have some experience, then maybe the observation is obvious to you, and I recommend that you try to make it obvious, because it's useful in many different situations. But probably the central idea here to make sure that the implementation is not that difficult is that whenever we have something that has some small length, especially if it has an odd length, but for even it works as well, we would like probably to think about what happens when we split the thing in the middle. So if we want a palindrome of length 3, what does that mean? Well, that means that we have 3 elements. The first is the same as the last, and the middle is whatever. And so, if we are going to find all of those palindromic subsequences, and if we focus on the middle element, then again, the middle element can be anything, and the element to the left and to the right have to appear in our string to the left and to the right, and of course they have to be equal. In other words, whenever we have 2 characters that are the same, then every character between them is a correct middle for a palindrome of length 3. So this is essentially the central observation in this problem. And when you have that observation, of course, we are being told here about subsequences that can be created by removing elements from the original string, but really that formulation of looking at the middle element, looking what's to the left, what's to the right, or looking at elements from the left and from the right that are equal, and looking at everything in the middle is enough to solve this problem. There are, of course, some maybe slightly faster solutions, slightly slower solutions, but the solution that I elected to implement and that I'm going to show is, first of all, we want to pre-calculate the leftmost and rightmost position for every character, because if we have that, then for every character that can be that left and right, everything that's between the left and right occurrence of that character is a correct middle character for a 3-length palindromic subsequence. So we do it as a dictionary or a default dictionary, however we prefer. And now we enumerate S to get the characters and their indices. And the left should be the minimum index and the right the maximum index. So whenever we see a character on an index, we update its right value and we only update the left value if the left value doesn't exist. So this is the first occurrence and this is the last occurrence. And now, for every character in ASCII lowercase, so for every lowercase letter, if that letter appears at all in our string, then we take the substring from the character to the right of its left occurrence, up to and not including its right occurrence. So those are all the elements strictly between the leftmost and rightmost occurrence of character C. So those are all the possible positions that will create a length-3 palindromic subsequence with our 2 letters. And now the thing that we have to remember is that we want to calculate the number of unique palindromes. So we have to here write set, and set of that substring is just every character appears at most once. And the number of characters is just the length of that set. And we sum it over all the possible characters that are on the wings of the palindrome. So this on line 9 are all the middle characters, and of course in this way we'll be calculating every unique palindrome exactly once, which is what we want.